Okay, so here we have technology where L and K are perfect substitutes, and we don't know the input prices, they're just W and R. So we want the input demand functions and cost functions. So in general, we know that the optimal condition is where your marginal rate of technical substitution, MPL over MPK, is equal to W over R. Okay? But when we have a linear production function like this, the MRTS is constant, it doesn't change. So, you know, it's a straight line, so the slope is constant. So what happens if this doesn't hold? Okay, so we're going to look at this. So what is MRTS in this case? First of all, well, it's just MPL, which is 2, over MPK, which is 4. So we have a production function with a slope of a half. Okay, so we're going to have 3 cases here. 3 cases where we're going to have this, that the MRTS is not equal to the ratio of the input prices. So let's look at the first one. So case 1, where MRTS is greater than W over R. Okay? So let's just say W is equal to 1 and R is equal to 3. So what's that going to look like? Something like this. Put L down here, K up here. Our isoquant is like this, with an MRTS of a half. In this case, our isocosts are going to have a slope of a third, W over third. W over R is going to be a third. Okay? So the isoquants are going to be steeper than the isocosts. So the isocosts are going to be shallow things, more shallow things like than the isoquants. So you can see, just drawing those things in, these are all parallel lines with a slope of a third. You can see that the firm is going to choose to produce down here. That's the lowest, excuse me, that's the lowest isocost line that hits the isoquant line. Okay. So what do we know about a point down here? Well, at this point, K is equal to 0. Okay. So the cost, our optimal K star, or our input demand for K, is equal to 0. What about L? Well, to find out how much L, just put K star is equal to 0 in there. We know that Q is equal to 2L plus 4 times 0. So we know then that L star is equal to Q over 2. Okay. What about the costs then? Well, we're going to have total costs for this case of W times L. So W, we just said, was 1 times Q over 2. We've no K, so total cost is just Q over 2. Which means that marginal cost then, of course, is just a half. That's our first case. What's our second case? Well, we'll just do the opposite. So in our second case, let's say that the MRTS is less than W over R. So let's say W is equal to 2 and R is equal to 3. What's the picture look like then? Well, the same sort of isoquant with an MRTS or a slope of a half. But now our isocosts are going to have a slope of 2 over 3. So they're going to be steeper. So they're going to be steeper, so say like this. So they keep on coming in like that. So they're all sloped 2/3. And you can see that the point that they're going to pick is going to be up here on the K axis. Okay? So they're going to pick L star equal to 0. And what's K going to be? Well, just putting L star equal to 0 into our production function, we get Q is equal to 4K, which means that K star is equal to Q over 4. So there's our 2 input demands in that case. And again, you can just go and work out the total cost. Straightforward. Total cost then is equal to, we've no W and L in this case, so it's just 4, which we've said is 3, times K star, which is Q over 4. Okay. Which is a linear function. So we've one last case. Case 3, where we go back and let our condition hold, where MRTS actually does equal W over R. Okay. So a case that would hold if, say, W is equal to 10 and R is equal to 20. What's it look like then? L in here, K up here. There's our iso quant. So MRTS of a half. And what's our iso cost? Well, our iso cost is the same slope. So there's going to be all parallel lines to this. Which I can't really draw. So there will be parallel lines to our iso quant, which means that they're going to actually be the same line, right? So our optimal iso cost is just going to be the same line as our iso quant. We're occupying the same space. What does that mean? W over R is equal to half as well. What does that mean? It means that any point along here is optimal. They can pick there, anywhere along there. And it's going to give them the same cost. So any point on the iso quant is a valid combination to minimize your costs.